In this PowerPoint video, we're going to learn how to write an equilibrium expression. There's basically only kind of two rules to writing an equilibrium expression, and we'll go over those in just a second. But they can ask you how to write an equilibrium expression in a couple of ways, and the little k, whatever they put, is almost a little bit on the irrelevant side. There's only one that's written slightly different, so we'll go over that. So an equilibrium expression is an equation in which the ratio of the product concentrations to the reactant concentrations is equal to a constant value. And that constant value, we use the letter K. So sometimes you'll see it written K with a little subscripted EQ. That's just a generic equilibrium expression. Okay, EQ standing for equilibrium. Another generic way that you'll see it is they'll say Kc, the constant for the concentrations. There's some more that look a little bit more specific, and the Kp is the only one that actually gets a different format because it's not talking about concentrations, it's talking about these partial pressures. And so when we write that, we write it a little bit different because they're not concentrations. Remember, concentrations use the little brackets, okay? So there's also some other specific looking Ks that you can have for your constants. They can say Ka or Kb if the thing you're specifically solving for has to be an acid or a base. And sometimes they'll say the Ksp, which stands for solubility product. So generally in this unit, we're going to be either calling it a KEQ, a KC, or a KP. We're not going to get more specific than that. They're all written basically the same, so there's not a different set of rules or anything. So once again, like I said, there's basically only two things that you're going to look at. When you start the equation, your equation has to be balanced. So you do have to have a balanced equation. And it is that chemists have found that there's a relationship mathematically between the concentrations of the reactants and the products once the equilibrium has been reached, and that it's independent of the initial concentration of the participants. So they've created a math equation, and the only two things you really have to look out for is that you've balanced your equation, as I already said, and that you look at the state of each ion or compound in the equation. Things that are solid or things that are pure liquids aren't written in your equations because their concentrations don't change. So how do you know if something's a solid? It's got that little parentheses down as a subscript with an S, and a pure liquid is going to have a letter L. Okay, we're going to keep everything that's gases and everything that's aqueous. So the concentrations of both aqueous and gases change during the process of a reaction. And for reactions involving a solid or a liquid, while the amounts of the solid or liquid might change during the reaction, their concentrations, much like their densities, won't change in the reaction. And since they don't change during the reactions, we don't include them. So their values remain constant, and because they're constants, their values do not get included in the equilibrium constant expression. So writing the equilibrium equation, it's as easy as pie. You are going to write the concentration of the products divided by the concentrations of the reactants, and they're raised to the power equal to the number of moles in that substance in their balanced chemical equation. That's why I said it had to be balanced. Now, when it says to the number of moles, hopefully you remember back to stoichiometry, that just means the big coefficient in the front of your balanced equation components. So it's also said the concentration of the products over reactants raised to the power of their coefficients. So if you're memorizing the formula for yourself so that you can quickly answer a quiz or test question, it's the concentration of the products over the concentration of the reactants raised to the power of the coefficients. The way I remember to put the products first is that I say alphabetically, products comes before reactants. So the only time that we're going to write any expression that looks different is if we're going to make a KP, because they are not going to use the concentration brackets. So when you use a KP, the expressions are talking about partial pressures, so they look slightly different. All it means, instead of the little square brackets, we use the parentheses, and we make a big letter P to indicate we're not talking about concentrations and that we're talking about the partial pressures. All right, so equilibrium constant is equal to the ratio of the products concentrations to the reactants concentrations at equilibrium. And so it's going to be equal to either a KEQ, a KC, or in this unit also a KP. So those are the three that we're going to be concentrating on. The first thing you need to have is an equation. And your equation is going to have coefficients. That's what these red lowercase letters are representing here. So you have to have a balanced equation. Then remember, the equation is written as the concentration of your products raised to the power of your coefficients. So the concentration bracket of your products, so I've got my C and my D, raised to the power of my coefficients. And that's over the concentration of my reactants raised to the power of their coefficients. So that's where these things are coming from. So it's an incredibly easy equation to write if you can balance an equation. Okay, so remember what the little brackets stand for. It's concentration. Concentration has units. It's either said moles per liter, which is abbreviated like this, which is also AKA the molarity of it, which is abbreviated like this. So it's got a couple different ways that you could correctly abbreviate that. And because all of these components have the same units of moles per liter, when you divide them, KEQ doesn't have any units on it. You know that we're sticklers for units, so remember the KEQ doesn't have any units. If you're talking about pressures, the only difference is we're not talking about concentrations, so we can't use the concentration brackets. Instead, we use parentheses and a large capital letter P here to indicate that it is the pressure of whatever it is here, whatever these elements or compounds are. So they have to be gases. They have to be gases in order to write a KP. So it is the reactants the reactants are going to be underneath here. So it's products over reactants raised to the power of their coefficients. So products over reactants raised to the power of their coefficients. So you've got to be able to balance an equation. They're going to give you pressures in atmospheres or torr or millimeters of mercury or kPa or any of those possible pressure units that we used back in gas laws. All right, so let's write our first equation. They have specifically requested that we write one for pressure. For that to be true, we've got to look to make sure that everything here is a gas, and it is. The second thing we need to do is we need to make sure that our equation is balanced. So I've got two n's, but over here I only have one n. So I've got to balance that equation. Now I have two. Now I have 6 h's, but I only have 2 h's. So I've got to balance that with a 3. So now I have a balanced equation. So now I can write my Kp. What does Kp equal? It equals the partial pressure of your products raised to the power of their coefficients divided by the partial pressures of your reactants raised to the power of your coefficients. I know it's early. Go ahead and pause the video for a second and see if you can write the equation. Hopefully the equation that you wrote was parentheses, the partial pressure of your NH3 raised to the power of your coefficient over the partial pressure of your N2. It's raised to the power of the coefficient. What's the coefficient here? A 1. You'll notice most of the time we don't write that number 1. And the partial pressure of your hydrogen gas raised to the power of your coefficient. So those are where those pieces are coming from. All right. So let's write the equilibrium expression for pressure again. So first step, that's right, balance your equation. Second step, check for your states of matter. Third step, write your Kp equation. Pause the video and write your equation. Okay, I hope you balance the equation by putting a coefficient of a 2 in front of the O2 and the NO2. Now it's balanced. Your equation is the pressure of your NO2 raised to the power of 2 over your N2 raised to the power of 1 over your O2 raised to the power of 2. In this next equation, they're asking you to write the equation. You have to write the equation before you can balance the equation. So write the equation. Hopefully you remembered that both hydrogen and iodine are diatomic. So my equation is going to come out to be H2 plus I2 yields HI, because both hydrogen and iodine have charges of 1. Hydrogen's a +1, iodine's a -1, so they're here in a 1-to-1 ratio. Balance your equation and write your Kp. Pause the video and make that happen. Okay, I hope the first thing that you did was notice that you needed to balance your equation. Your equation balanced with the 2 coefficient. Then the next thing you needed to do was write your expression. If you have not written your expression or you didn't balance your equation, pause the video and write your expression. Okay, your equation should have come out to be the concentration of your hydrogen iodide gas to the power of your coefficient over the hydrogen raised to the power of the coefficient of 1 and your iodine to the power of the coefficient of 1. Now, before it asked you just to write a basic equilibrium expression, you could have also written this, because everybody here was a Kp, you could have also written this as the following. The partial pressure of your hydrogen ion concentration, but it's a hydrogen ion partial pressure instead of concentration, over the partial pressure of your hydrogen gas raised to the 1, the partial pressure of your iodine raised to the power also of 1, which we typically leave off. Now, how do I know which reaction equation to write from my reaction? I do it based on what the question says. So they specifically asked me for a Kp, that's what I'm going to write. Okay. If they specifically asked me for an equilibrium constant expression, I could, in this case, write either one of these, because they didn't expressly tell me to talk about concentration. So either one of those could have been a correct answer, unless the question specifically asks for one or the other. Please read your questions carefully. All right, our next equation says to specifically write a KEQ. What's the first step? Balance the equation. So go ahead and balance this equation. Hopefully when you balance this equation, you put a number 2 in front of your CL. That balanced your equation. The next step is to check to see if you have only the right states of matter here. Remember, we don't include solids or pure liquids. And I've got a solid in my calcium chloride here. So it's not included in my reaction equation. All right. So I'm going to write my equilibrium expression. KEQ equals the concentration of my products raised to the power of their coefficients divided by the concentration of the reactants raised to the power of the coefficients. But remember, we don't incorporate solids or liquids. They're not included in our reaction. So we leave them out of our expression. That is either left out this way with the number 1, or you don't even have to write this number 1 here at all. It could have just been this top piece of the equation. And we don't have to write that 1 there either. So, well, a 1 is just understood. All right. First step, balance your equation. Second step, look to see what the question is asking you for. It's asking you for a pressure. So we're going to write a KP. Everybody in a KP has to be a gas. So double check that, because maybe there's some sort of error in the question. So it's not. Everybody here that's going to be left over is a gas. We don't have any other states of matter here. So I balance my equation. When I balance my equation, I get a big 2 in the front of my nitrogen dioxide. And now I'm going to write a KP. Pause the video and write your KP. Hopefully this is your equation. The partial pressure of your dinitrogen tetraoxide raised to the power of the coefficient. Of course, there's no number there, so technically that's a 1. Divided by the partial pressure of your nitrogen dioxide raised to the power of the coefficient. That's where I'm getting that number 2 from. Okay, so on our equation for the next problem, balance the equation, check your states of matter, write your expression. They're asking you here for an expression for pressure. Go ahead and pause the video and write that equation. Hopefully you noticed that the equation was already balanced. There were no coefficients needed. And hopefully you noticed that there were solids in this equation, and we don't incorporate solids in any equation, and they definitely can't end up in an equation for pressure. Then you are going to write your equation. The equation ends up being only this one component. It is a product, so it is the partial pressure of your carbon dioxide gas raised to the power of the coefficient, which is a 1, and generally we don't write the 1s. Write the equilibrium expression for the following equation. They were kind enough to already balance it for you. So your next step is to check to see the states of matter. Everybody here is aqueous, so it's not a solid or a pure liquid, but it's also not a gas, so we're not going to write a KP for this. We're going to write a KEQ, and they're telling you write an equilibrium expression. That just means a generic equilibrium expression. So go ahead and pause the video and write your expression. Hopefully your expression came out to Cl-1, the chloride, ion raised to the power of 2 over times, the concentration of your chlorate ion raised to the power of its coefficient, which is a 1, over your hypochlorite ion raised to the power of its coefficient, which was a 3. Remember, when it's a 1, we often leave it off, so that's why we didn't put a little number 1 there, even though when you don't have a coefficient, it is a 1. Write the equilibrium expression for the following equation. Pause your video and write the equation. Okay, so hopefully you noticed that you needed to cancel out your zinc solid. Solids are not written in equilibrium expressions. It is the concentration of your hydrogen gas over the the concentration of your zinc ions raised to the power of their coefficients, which were both 1s, over the concentration of your hydrogen ions raised to the power of your coefficients, which here was a 2. Now you'll notice here they wrote the zinc second and the hydrogen gas first. It doesn't matter because these things are getting multiplied. These two things that are right next to each other are getting times by each other. So it doesn't matter whether I put the H2 first or the Zn plus 2 first. They're both going to be multiplied, so it's irrelevant. All right, write the Kp expression for the following equation. You'll see they were kind enough to balance it for you. Because they asked you for Kp, hopefully you use the partial pressure symbols with your parentheses. So parentheses, the partial pressure of your O2 times the partial pressure of your SO2. That SO2 is raised to the power of 2 because of its coefficient, over the partial pressure of your SO3 raised to the power of your coefficients. So remember, whenever it's a 1, we typically just leave that off. All right, pause the video and write the Kp expression for the following reaction. Hopefully you saw it's already balanced. Hopefully you saw that it has only gases. They told me to write a Kp, so I'm using the parentheses and making Kp equal to the partial pressure of oxygen gas raised to the power of its coefficient and the partial pressure of ozone raised to the power of its coefficient. That's where these numbers came from. They were the coefficients. Pause your video and write the Kp expression for the following equation. Hopefully you saw that this equation was already balanced. Hopefully you saw that they gave you a solid which you do not put in an expression of any kind. They can definitely not go in a Kp. Then you wrote your expression. You wrote your expression to be the partial pressure of your CCl4 raised to the power of the coefficient divided by the partial pressure of your chlorine gas raised to the power of the coefficient. Write the Kp expression for the following reaction. Pause the video and write your equation. First thing you had to check was to see if your equation was balanced. 1 mg, 1 mg, 1c, 1c. 3 O's, 3 O's. So it is indeed already balanced. The second thing you should have done was to notice that you needed to cancel out things that were solid or liquid. Now you can write your Kp as the partial pressure of your carbon dioxide gas raised to the power of the coefficient, which in this case is a 1. If you had trouble with any of these problems, please copy and paste the problem specifically that you had trouble with and put it on your teacher's discussion board. The discussion hours are posted on your Canvas course. It's important that if you have a question about any of your problems, you ask for help. It's up to you. Thanks, and see you again on your next video.